Okay, in this video I'm going to demonstrate the use of the log transformation and square root transformation when working with a left skewed distribution, basically a negatively skewed distribution. So the variable that we're going to be working with is this one right here, XLS. It's just not a very creative name, but it's just basically our variable X, which I'm just saying is left skewed. Let's first take a look at this variable. I'm going to go to descriptive statistics to explore, and we're going to move XLS over, and under plots we're going to ask for histogram, normal probability plots with tests. Click on OK. So you can see that looking at our skewness statistic right here, it's negative. Basically, when interpreting skewness statistic in SPSS, a value of 0 is consistent with a symmetric distribution. Positive values indicating positive skew, a negative value indicating negative skew. So looking at our histogram, you can see that you can see the skew in the data. So just kind of drawing a little bit of a curve over all this, you can see the negative skew right here. Looking at Kolmogorov-Smirnov Shapiro-Wilk test, you can see that these p-values are significant, suggesting significant departure from normality based on our data. Do note that Shapiro-Wilk tends to be more commonly utilized with lower ends, Kolmogorov-Smirnov with higher ends. So that's just a little something to kind of note. All right, so when transforming our variable using these procedures, what we'll want to do first is to reflect the variable. So in other words, basically when we have data that is right skewed or positively skewed, the basic idea behind performing a log transformation or a square root transformation is to kind of pull that tail in. And so basically all of the scores are affected by the transformation, but the ones that are in the upper tail are going to be affected more than those in the lower tail. So you can see right here, though, that our distribution is negatively skewed. So in this particular case, what we'll want to do is to reflect it so that our distribution looks more like this, then perform the transformation, and then either reinterpret our variable in light of that transformation, or re-reflect the variable so that the direction is more consistent with your original meaning for your variable. So what we'll do is reflect the variable. So to do this, what we'll do is we'll go to Analyze Descriptive Stats. We want to look at and find the highest score in the data set. So the highest score on our variable XLS is 52. And so what we're going to do is we're going to create a new variable that's a reflected variable, and I'm just going to call this reflected X, and we'll take 1, we'll add 1 we'll take the highest score, which is 52, and add 1. So it's basically 1 plus 52, which obviously is going to be 53, and subtract from that our original variable, which is the XLS. So I'm going to click on OK. And so now we've got our reflected variable that appears in the data set. So this is it right here. So if we look at our Explorer and just kind of look at the characteristics of this variable, now you'll notice that skewness, previously it was negative 1.144, now it's positive 1.144. You can see the tests for Shapiro-Wilk and Kolmogorov-Smirnov were both the same. And just looking at the distribution, you can see that now it's positive instead of negative. So now we can perform our transformations. So we'll go to Transform, Compute Variable, and in this case, I'm just going to create a log, natural log. So I'll just call this log of x, and I'll just kind of move. I'll just type in ln, and then the reflected variable in parentheses here. Click on OK. And so now that variable appears. Now I'll do the same in terms of creating a square root transformation. So of x, and then we'll just type in sqrt, and then use the reflected variable in parentheses. So just note the target variable name is up to you. so it's arbitrary, but this part is what you'll have to type in. So now we've got our two new variables that are listed. So next up, what I will do is just take a quick look. I'll go to Explore and look at these right here, and you can see that in terms of the skewness value for the log of the reflected variable is negative 0.966. For the square root of x, it's 0.231. So you can see that the absolute value of the skewness statistic is much closer to 0 with the square root of the reflected variable than the log of the reflected variable. So I would be inclined then to choose the square root of x rather than the log of x in any subsequent analyses that required normality of the x variable. So you can either, like I said, when it comes to running subsequent analyses, like if you're running regression analysis using x, and let's say you decided to perform reflected x, and then perform a transformation. If you don't reflect back, then you would want to interpret the sign of the regression coefficient in the opposite direction of what you had originally planned on. Another option is just to essentially reflect this variable back. So to do that, what you can do is, again, look up the maximum value in the data set for that particular variable, which in this case is 7.21. So what we'll do is we'll go to transform compute, and then we'll just call this square root of the reflected x, and we'll say 7.21 plus 1 minus the square root of the reflected x. So click on OK. And so now you'll see that looking at our variable, this is it right here. So if we look at, go back to Explore, and let's just compare that with the pre-reflected x, or square root of x, you can see now that the square root of x, the skewness value was 0.231, whereas taking the square root, or basically reflecting that square root at x, gives us the negative coefficient of negative 0.231.